Hey, what's up, guys? This is Sean here. So this time, LeetCode number 446, arithmetic slices number 2, subsequence. Right. So given like integer array nums, right? Now this time we need to return a number of all the arithmetic subsequences. So the definition of arithmetic subsequences is first it has to be at least 3 elements long, right? And second is that any difference between two neighbors elements needs to be the same, right? So pretty straightforward. And for example, we have 2, 4, 6, 8, 10, right? So the answer is 7 because obviously for all the subsequences that only has length 2 are not false are not in our answer. That's why only the 3 lengths and above are considered, right? That's why we have 2, 4, 6, this, right? The answer is 7. And for this one, it's 16 because all the difference are 0. So the constraints are like this: it's 1000, and then the number itself is a regular integer, right? So for this one, I mean, a brutal force way is of course is the try to generate all the subsequences, right? And to generate all subsequences, the time complexity is gonna be a 2 to the power of n, right? That's gonna be the total time complexity, right? So where does this one come from? I think this one's from like this, right? So for this one, let's say we have A and B, right? So for A and B, we have what? We have 4 subsequences. We have A, we have B, we have AB, right? And then we have empty, right? And then if we add a C here, right? So basically we're adding 4. We're adding 4 more, which is AC, BC, ABC, and C, right? And if we're adding like another D here, basically this is plus 4. This we have gonna be a plus 8, right? So as you guys can see, every time we add a new letters here, we always double what we have before, right? That's where it's 2 to the power of n come from. But this one, and then to do the comparison, right? For each of subsequence, we need to check if the subsequence is arithmetic, right? And then we need to do another like times n to check for each of the subsequence. This one will definitely lead to a TLE. Okay, so that's why we need a better solution, right? So how do we do it? I think we already saw it. Basically, we have these 2 numbers, right? And then every time we add a new one, right, we just add the previously total numbers, right? So that we can simply use that, right, to help us find the final answer, right? Which means, let's say we have this, right? We have this one, and let's say for this I here, okay, this is I. If we know, let's say this is J, right? So let's say this is I and J. So let's say from J to I, the difference is 4. Okay, right? So the difference is 4. So this is the difference. So if we know on index J, right, ending with index J, and the number of subsequences, the arithmetic subsequences whose difference is 4, let's say is 5. There are 5, or let's say there are 10. There are 10 subsequences. Start from 0 and end with J, right? End with J whose difference is equal to 4. Then we know, okay, so then from J to I, we can just inherit those 10 to I. Basically, we can do a plus 10 because we know this is exactly how this one works, right? Basically, we just whatever we have from J, we can inherit to I because, like I said, we just append that. We just append that everything that we have from J with this I to so that we can construct to a new subsequence, right? And if we have a multiple numbers that can have the same difference, let's say there's another J here, right? Let's say from this J, to this I, the difference is also 4, right? It's possible, right? There could be two same numbers here. And then what? And then we just simply just accumulate whatever we have from here. Let's say this one has like 8 different subsequences, and we do a plus 8, right? So that's how we get the total value of this one. So that's why we need like what? We need a two-dimensional DP, right? We have DPI, and then we have difference, right? DPI and difference here. So where I is the index and difference, it means that at the current I, and the difference between each number is this diff, right? And how many subsequences we have there. Okay, right? And this is cool. So that's that, right? And this one will become the state transition will be the dp of j, right? Of diff dj, right? And then j is within the range from 0 to I minus 1, right? So that's that. But we have there's like this, at least three elements is needed, right? So which means we cannot simply blindly use the state transition function, right? So what we need to use is that when you somehow start with a 2, right? Then why is that? Because our base case is like this. Let's say if we have 1, 3, 5, right? So this one, the answer is 1, right? So how can we initiate that? What we can do is that so let's say that the minimum length is 3. So if we have a so which means for each 2, okay, so for 2 length, if we set 2 lengths to 1, right, to value to 1, and the next time if we added another one here, right, then we know, okay, by adding one more, so we can inherit what we have from previous one to this one. That's why we will have 1 in this case, right? Okay, and when we update the DPI diff here, from DPJ to from DPJ diff, we also need to do a plus 1 to what? To add that length 2 scenario. Okay, so what does that mean? It means like this. Okay. Okay, oh, sorry, maybe like this one. Okay, so let's say we have this 2. We have 1, 3. Okay, 1, 3. Okay, so basically at this place, right? So this one, the value of this 1, 3, we set it to 1. Basically, we set dp of this I 2 equals to 1, right? That's the difference. And then when we have 5 here, right? Then we know, okay, so from 5, okay, we see, okay, so we have 1 from at dp this index with difference 2 equals to 1. Then we know, okay, so we can have 1 for 5, right? But when let's say this is 0, 1, 2, basically the dp of 1, 2 equals to 1, right? Now we're at 5. So we're at 5. It means that we have at 5 2 and 2 and 2, right? So this one, so what is the value for this one? Okay, so basically when we add 5, so this one goes to answer, right? And then how about we update 5, because we need to update 5 in case we have another 7 after that, right? When we update 5, we cannot simply just we shouldn't just simply carry over whatever we have from 1, right? Because if we just do this from 1, this is wrong, because we need to do a 1 plus 1. And why is that? Because this 1 means that, just like why we initiate this this 0, while we initiate this 1 2 into 1, we also need to initiate this 3 5 with 1. So basically this one in the end is it's a length 2 case for 5 and 3, right? Because because next time we have 7, right? So from 7, when we add 5 here, 3 5 and 7, this is also like a valid arithmetic subsequence, right? So every time when we update the current one, we besides carrying over from previously dpj diff, right? dpj diff, we also need to do a +1 in the end. So this 1 means that it's whatever we have. Basically, this one is what this one is the from j to i. This is the length 2 because we need this one to be ready there, right? To set there, to be included, so that the next one can use that as a base. Because yeah, like I said, with this 2, if we have a third one coming in, right, adding this previous 2 numbers, then it will form to a valid subsequence, right? So if we don't add 1, basically we'll be missing the 3 5 7, right? Because like I said, this dpj diff this jdiff is the represents the previous one, right? Ending with 3, right? This one, I mean, we're assuming this one it at least length 2 has length 2, right? So that's why we'll have like something 3 and then 5 and 7. But if we don't do +1, basically we'll be missing with 3 5 itself 1, right? If we only inherit this jdiff, that's why we need to do an I here, just to include another 2 case, right? To start with j, and then start with j and end with I to include that. Okay, right now then right? So in the end, we cannot simply accumulate everything from this dp, I, and diff, right? Because obviously the value we stores here also includes several length 2 values, right? This length 2 values are just some candidates in case there are like in the futures we need those values, right? That's why the answer has to be coming from this one, has to be coming from this value, because that's the valid length 3, at least length 3 subsequence we'll get, because at least this, like I said, we're assuming this one is at least length 2, right? And then if we do from length 2, if we add another number, that will be guaranteeing that it's a length 3 subsequence. So that's why this part is the answer, right? And we cannot do a sum in the end to everything in the DP, which is wrong. Okay, I think that's it, right? I mean, let's start coding then, right? Okay, so we have a length of nums. Okay. Oh, did I mention that? Okay. Maybe I forgot to mention. We have DPI and difference, right? Since the range of the value is pretty big, and we cannot simply use a 2-dimensional array for this DP, because then the second dimension will be too big. It'll be 2 to the power of 32, right? Then it will exceed the maximum space requirements, right? Limits. That's why the way we improve it, instead of using a 2-dimensional array, for the second dimension we can use a dictionary, because since the number is only it's not that big. That's why the possible different values is also limit bound with this 1000 value, right? So what I mean is like this. So for DP, usually we do like this array, right, somewhere inside. But here, this time we're gonna use like a dictionary instead. Default dictionary, right? Int for this in range of n. Okay, and then we have the answer equal to 0, and then for I in range 1 to n, right? Because a single number doesn't mean anything. That's why we need at least 2 numbers to start with. Okay, so for j in range of I. Okay, so first let's get diff numbers of I minus nums j, right? And like I said, the answer comes from the dp of j diff, right? And then when we update the current dp I of diff, right? So first we accumulate everything from the j diff, right? And then second we do a +1 in the end to include the pair of j and I as a length 2. Okay, and then we return the answer in the end. So I think that's it. Yeah, cool. So pass, right? And okay, since we're using a default dictionary, we don't need to worry about us checking if this diff exists in this dpj or not, because if it doesn't exist, then it simply will give us a 0, right? If you don't use this one, you might want to check that, because the first time when it doesn't exist, right, it means we need to set it to 1, right? That's exactly what this one will give us, right? Because this when it doesn't exist, when this diff doesn't exist in I, this one will become to 0, right? Sorry, when the diff doesn't exist in J, right, then this one will be 0. That's why this one will simply just be a +1, right, to account the ji pair, right, for the future use. Yeah, and as you guys can see, this one is n square time complexity, right, for both time and space. Cool, I think that's it for this one, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.